Huh. Hope you are doing good. And today we are going to solve problems from MIT Integration BA 2015 without preparation. Right? In the last video we have done for 2014, and I think we have already done 2013, 2012, 2011, 2010. Now it's time for 2015. Today we are going to do that, and I'll try to do it without. I haven't really prepared for this one, but I just hope that it goes well. Yeah, let me see if the live is working well. Yeah, let me see if the live. Oh yeah, I think it's working well. Let me just tilt my screen, I guess. Yeah, I think this one will be good because this works for both PC and mobile devices, right? Okay. This works for both PC and mobile devices, right? Yeah. Okay. So I can see that 4 people are watching. So yeah, I think we are good to go, right? So you can comment if you are ready, guys. Shall we begin? Okay, so those of you, 4 of you or 2 of you who are watching, shall we begin? Let me also share this with some of my friends. I think I can do it. Okay, wait. I'll just share this and we will begin. I will not take a lot of time. I'm sorry. So share, copy link, and messenger. So let me share this with. Where's that group? Yeah. Guys, you can join if you want to. Okay, good. And then also let me see it in the next group, which is the next group. I can find that. I think it's fine. Okay, I think this one is fine. If people want to join, they will definitely get the notification and they will join. Yeah. Okay, shall we begin, guys? Yes, Sanjay. Sankal, nice to see you. Okay, so we are going to do the problems from MIT Integration B 2015. So we have already done for 2010, 2011, 2012, 2013, 2014, and now this time 2015. So yeah, let's begin. We also have the answers over here. We'll check the answers after we solve the problem, and yeah, I think we're good to go. And guys, Sankalpa and others, whoever you are, you can let me know if you have any doubts in the solution, right? I will try to clarify as much as I can. Yeah. Okay, let's begin. First problem is cos 4x minus sin 4x dx. 1 integral of cos to the power 4x minus sine to the power 4x dx, right? So how do you think we're gonna approach this integral? I think that for me, the factorizing would be a best option. So let us just factorize this. Cos square x minus sine square x, cos square x plus sine square x dx, right? And now we know that the sine square x plus cos square x, this is just 1, right? The reason is sine x is just p by h and cos x is b by h, right? And if you add their square, this will be p square plus b square by h square, which is h square by h square, so that's 1, right? This is, now again, cos square x minus sine square x, this is the formula of cos 2x times, this is 1 dx. Now integral of cos 2x is just sine 2x, and since x has coefficient 2, divided by 2 plus c. So this is sine 2x by 2 plus c. That makes sense, right? This one was not that hard. And let's check the answer. Oh, wait. I'm sorry. Okay. Yeah, sine 2x by 2. Let's go to the next problem, which is integral of x by square root of 2 plus 4x dx. Next is integral of x by square root of 2 plus 4x dx. So how do we approach this one? So what I think we should try to make this expression the same as what's there in denominator. So for that, first of all, I can take 1 by 4th to make this one 4x divided by square root of 4 plus 2x dx, right? After that, what I can do is I can introduce a plus 2 and minus 2 divided by square root of 2 plus 4x dx, right? So now this will be 1 by 4 times integral of square root of 2 plus 4x minus 2 by square root of 2 plus 4x dx, right? Now I think I can write this as 1 by 4th square root of 2 plus 4x minus integral of 1 by 2 square root of 2 plus 4x dx, right? Yeah. Now after this, we know that integral of some power x to the power n will just be x to the power n plus 1 by n plus 1, right? Let's see. Using that, we get 1 by 4. This will be 2 plus 4x to the power 3 by 2 by 3 by 2, because initially the power is half over here, and also we need to divide by the coefficient of x, which is 4, minus over here we know that the integral of 1 by 2 root x is just root x, right? So using that, this will be square root of 2 plus 4x, and also divide by the coefficient of x, which is 4, plus c. So this is the solution. Now we get the answer to be, this will be 4, 8, 3 is a 24. So 1 by 24 times 2 plus 4x to the power 3 by 2. 1 by 2 hunna need the second term. Okay, so because there's a 2 and 1 by 4 over here, so 2 and 1 by 4 they multiply to give 1 by 2. I think that makes sense, right, Sankalpa? Or like, is there anything else? I have just multiplied this by 1 by 4 to the both of the terms. Let me know if that makes sense or not. Like, if do you really think I made a mistake over here? It multiply okay, okay, good, and thanks for asking. And also let me know if you have any doubts in the further steps. Now this is minus square root of 2 plus 4x by 4 plus c. This should be our answer, right? 2 plus 4x to the power 3 by 2 by 24 minus, yeah. Let's check the answer. Okay, wait, how do I get it down? The answer is, what's the answer? Oh, it's in slightly different form. So let's try to change it to this form, into the given form, where there are just x minus 1, and so let me try it this way. Now let me try to take square root of 2 plus 4x common, divided by 4. Now that will make it just 2 plus 4x divided by 6, right, minus 1 plus c. And now that will be square root of, if I take 4 common, that will be 2 by 4 x plus half, and then this will be 2 plus 4x minus 6 divided by 6 plus c, right? and now this will be half times square root of x plus half, and then this is 4x minus 4 by 6. So that is that will now be square root of x plus half, and then x minus 1 divided by 3, right? Yeah. So now I think now that does this match the answer? I think it makes sense, right? So I'll go to the next problem. Yeah. Integral from 0 to 8 cos root x by root x dx. So let's try this one. Let's try this one. Would you want to try it first before I do? Integral of cos root x by root x dx. So I think the strategy for this problem would be to make a u substitution, right? If you make a u substitution that u is root x, we will have du is equals to 1 by 2 root x dx, and so we will get 2 du is equals to 1 by root x dx, right? Now using that, what I can get is this will be integral of root x is just u, and 1 by root x dx is just 2 du. So now this has become a pretty simple problem. Just the integral of cos u du, which we know is just sine u, right? And we know that u is just root x. So the answer is 2 sine of root x plus c. So let's check the answer. Oh, we have limits. I forgot that. The limits are from 0 to 8. So let us substitute the limits now from 0 to 8. Sorry, 0 to 8, not infinity. So this is 2 sine square root of 8 is 2 root 2 plus c minus this is 2 times sine 0 plus c, right? So this is 2 sine 2 root 2 plus c minus 0 minus c cancel out. So we have 2 sine of 2 root 2, right? So the answer is 2 sine 2 root 2. Yeah. Let's go to the next one. Integral of sec x dx, and the answer over here is sec as inverse x cos x. Okay. Integral of sec x dx, right? Yeah. Integral of sec x. Integral of sec x dx. Okay. So what do you think we should do for this problem, guys? Oh, there's just one person on the live right now. Yeah, it's fine. Yesterday it was around like average of 4 people, and the maximum was about 11. But it's fine. We'll just keep on going. Maybe like people will watch the record version. Yeah. Okay. Now let's do this one. So we definitely have a direct formula for the sec x, which is ln of sec x plus tan x, and we solves the problem easily, right? But let's try to get the answer that's over here, which is sec h inverse of cos x, right? Sec h inverse of cos x. Now how can we get that? So how do we get that? Like, do you guys know the derivative of sec h inverse x? Derivative of sec h inverse x. What it is? I don't know, like, what's the derivative of sec h? Okay, so, okay, let's do this. We know the derivative of sec h x, right? It's minus sec h x tan x. Okay. So if you know this, now, okay, so say y as sec h x, and then we know that dy by dx is minus sec h x tan x, and this is dy by dx is, this is minus y, tan x is, since sec h square x plus tan h square x is equals to 1, we know that tan hx will be square root of 1 minus sec h square x, right? So tan hx will be square root of 1 minus y square, because y is sec hx. So then dx by dy will be minus y by y root 1 minus y square, right? So yeah, so since dx by dy is this thing, yeah, though now we know that x is just sec h inverse y, right? So d dy of sec h inverse y is negative 1 by y root 1 minus y square. Now I can write x for y. So d dx of sec h inverse x is negative 1 by x root 1 minus x square. So let's try to use this. So if you want to use this, I will try to write this as, so sec x is there, right? Now let me write it as sec x1 minus cos x. And let me introduce sin x over here, dx. Now what I'm trying to do is, if I let y as cos x, over here this should be 1 by y and root under 1 minus y square. This will be minus dy, right? And now minus 1 by y root 1 minus y square dy. We know that this is just sec h inverse y. And we know that y is cos x, so this is sec h inverse cos x, and we have proved the claim. Let's see. How was that? I do hope you enjoyed the solution, right? Let me know if you have anything, and let me know if you want to take a screenshot, I guess. But this is a live video. You can just go back and watch it. No need to take a screenshot. Okay. So let's go to the next problem, shall we? Next one is integral from 0 to pi by 2 of e sin x divided by tan x cosec x dx. Okay. This one seems to be a really good problem. Integral from 0 to pi by 2 of e to the power sin x divided by tan x cosec x dx. E to the power sin x divided by tan x cosec x dx. Do you guys, 5 of you who are watching, do you guys want to share ideas how I can solve this problem? I would love to try your ideas before I try mine. So 5 of you who have watched from 0 to pi by 2. If you want to share your ideas, I'm happy to try what you have on your mind. So let me know if you have anything. Okay, no? Okay, it's fine. So let's solve it together. So how we can solve this one is, so first of all, let's just simplify the expression. Even I don't know how to solve right now. So let's just try to simplify it first. We know that tan x is just sin x by cos x, right? And cosec x is just 1 by sin x, right? Dx. Now the sin x definitely cancels out. And the cos x goes to the numerator, right? Guys, now you can see how to solve. I think now it's pretty easy. Now, yes, exactly, Sankalp, exactly. Now let's make the substitution u as sin x. If you make that substitution, the limits will now go from you see u sine of 0 is just 0, sine of pi by 2 is just 1, and then e to the power sin x is u, cos x dx is du. Because Sathi Ali advertise Gora K, something like that. Okay, sure. अब बिस्तारै गर्नुपर्छ हैन, अब गरौँ न नि. ल ठिक छ. अनि यसपछि okay, now after this, now integral of e to the power u. Simple power, to get e to the power u divided by u square. I got the simple expression. Okay, now I think the integral is just e to the power u going from 0 to 1. So this is e to the power 1 minus e to the power 0. So e minus 1, and that is the answer, right? Let's check it. E minus 1, yeah. So let's go to the next one, right? Integral from 1 to e of x log x square dx. Integral from 1 to e. Okay, so what's the number of this problem? 6 of x log x square dx. Integral from 1 to e of x log x square dx, right? So let's try to solve this problem. Now, what do you think we will use? I think it's better to use just integration by parts, where this be the u and this be the v. Yeah. So this will be log x square, and then integral of x is just x square by 2 minus integral from 1 to e. Derivative of log x square is 2 log x 1 by x times the integral of x is x square by 2 dx, right? 2 cancels out. So we have x square by 2. Yeah, e to the power u mother is yes. X square by 2 log x square minus integral from 1 to e. This is log x times x dx, right? Now again, let's use integration by parts. X square by 2 log x square minus integral from 1. Okay, now again use integration by parts for this one. So that will give us log x times the integral of x is again x square by 2. Now the minus will become plus, and then integral from 1 to e. Derivative log x is 1 by x. Integral is x square by 2 dx, right? So we have x square by 2 log x square minus x square by 2 log x plus, now there will just be x by 2, which is x square by 4. All this from 1 to e, right? Now let's first simplify this. This will just be x square by 2 times log x square minus log x plus 1 by 2, right? Going from 1 to e. So this is just e square by 2. Log of e is 1 square minus 1 plus half, and then minus 1 by 2. This is 0 minus 0 plus half, right? So finally this is e square by 2. Yeah, log x one base here. Yes, until and unless I'm like base 10, until and unless we are told that the base of the logarithm is 10, we should assume that the base is e. Do you get that, Sankalpa? Until we are told that the base is 10, we should always assume that the base is e. So e square by 2, this will just be half minus this will be 1 by 4th. So this will be e square by 4 minus 1 by 4, which is e square minus 1 by 4. So yeah, this is the solution, right? This was just integration by parts. We applied that multiple times and we got the answer. This is a standard problem from grade 12. So yeah, e square minus 1 by 4, that's the answer. Let's go to the next one, 7 number. Integral of 1 by 5 plus 4 root x plus x dx. So 7 number. Integral of 1 by 5 plus 4 root x plus x. 5 plus 4 root x plus x dx, right? Yeah. So basically I'm doing this live session so that like many people will like get the help, like they will get the exposure on integral big problems, basically just to share the awareness about such things, right? So yeah, I hope you guys would help in that mission by helping with, like, sharing it with others as well. Okay, now let's see how to solve this one. So basically, since there is a root x over here, what we will try to do is make a substitution with root x, right? Because while solving integrals, most of the time our the only goal is to simplify it so that we can use some formulas to find the integrals, right? So always, first of all, try to simplify the expression. So that's what I'm gonna do here. Now this is u square is equals to x, right? So this will be 2u du is equals to dx. Yeah. And so integral of dx is just 2u du by 1 plus 4u plus now x is u square. right? Now, notice that, like, if you make a substitution again, that t is 5 plus 4u plus u square, dt is going to be 4 plus 2u du, right? Now we already have 2u over here in the numerator. So what we will try to do is, we will try to introduce a plus 4 and then a minus 4. Okay? So 5 plus 4u plus u square times du. Now this is integral of 2u plus 4 by 5 plus 4u plus u square minus integral of 4 by 4u square plus 4u plus 5 du. Okay? So now, notice that over here also, let me write du. We now know that this 2u plus 4 is just the derivative of 5 plus 4u plus u square, right? Divided by 5 plus 4u plus u square. And over here, I will change this to the the square form. So u square plus 4u plus 4 plus 1. Now the reason I've done this is, after I write this in this form, now I can write this as u plus 2u square plus 1 square. And the reason I'm taking it in this form is, we have a standard integral of this form. That integral of 1 by x square plus a square dx is just 1 by a tan inverse x by a. So I'm trying to use this formula. And also, for the other integral, we know that if we have d of f of x by f of x, the integral is just ln of f of x. It's the same. They're like how it is when we have dx by x, which is ln x. Right? Now, this is just ln of 5 plus 4u plus u square minus, now this is 4 times 1 by the a is just 1 tan inverse u plus 2 divided by 1 plus c. Now we know that u is just root x, right? So using that, we get ln of 5 plus 4 root x plus x minus 4 tan inverse root x plus 2 plus c, and that is our answer. Like, does that make sense? I think this one is just some manipulation, right? Now let me check the answer. ln of right. So I'll go to the next problem. Integral of 2015 to the power x dx. Integral of, what's the number? 8. Okay, 8 number. In 8 number, guys, the 6 of you who are watching, please like don't hesitate to ask your doubts if you have. I'm happy to answer them. So integral of 2015 to the power x dx, right? Now how do we do this one? This one is basically just based on a standard formula, that integral of a to the power x dx is just a to the power x divided by ln of a plus c, right? So let's use this formula. So that will be 2015 to the power x by ln of 2015 plus c, and that's the answer. This was too easy. Right? So 2015 to the power x by ln of 2015. Yeah. Let's go to next one. 9 number. Integral from 0 to 2 of x divided by x minus 3 x plus 5 squared dx. Integral of x divided by x minus 3 x plus 5 squared dx. Is this the problem? Integral of 0 to 2 x by x minus 3 x plus 5 squared dx, right? From 0 to 2. Okay, let's do this one from 0 to 2. So now let's see how we can solve this one. So guys, what do you guys suggest? Like the use substitution or manipulation or integration by parts or rational functions, like breaking into parts with fractions? What do you guys think would be a good option? I think you guys can clearly see that since the denominator is in a kind of product of multiple expressions, definitely we should try partial fractions, right? And yeah, if you are thinking that, you are right. So now let us use partial fractions. So x by x minus 3, x plus 5 square. This will be a by, we know that this can be broken into a by x minus 3 plus b by x plus 5 plus c by x plus 5 square, right? Now if any of you are thinking that why don't we break this as a by x minus 3 plus bx plus c divided by x plus 5 square. If any of you are thinking that isn't this possible, can you not do it this way? Yeah, then your concern is valid. Now basically these two are the same. Let me show you. So we can basically write this as a by x minus 3 plus, I can introduce x plus 5 minus 5, right, plus c by x plus 5 square, and that will be a by x minus 3 plus bx plus 5 and then minus 5b plus c divided by x plus 5 square. Now this is, oh, I forgot the x square over here. Now this is a by x minus 3 plus b by x plus 5 and then plus, let this minus 5b plus c be another constant, right, c dash divided by, because these are just some numbers, right? So numbers plus numbers will be another constant, so c dash by x plus 5 square. So do you see that, you see that these two are actually the same, right? So either of them is valid. Now let's go to the solution. Okay, now let's go to the solution. Now how do we find a, b and c? So first of all, let's multiply them. A x plus 5 square plus b x minus 3 x plus 5 plus c x minus 3. Yeah, exactly, signal it's partial fractions. Now this is x times a x plus 5 square plus